Welcome, guys. Still on reduction formula. Considering the questions we have here, um, we have to generate the reduction formula for tan nx, for cot nx, for sec and cosec. So we are going to be using the same process in what you have actually learned in from lesson plan A and plan B. So let's start the work. Solution to this. So we need to take this one by one. Remember I said that to solve questions like this or questions on reduction formula, the first thing you need to do is to make an assumption. Let in represent integral of tan nx dx. So guys, this is what we have. Let in be equals to integral of tan nx dx. So for me, what's the next thing to do? Remember I said that for all these, I think from lesson plan B, I said that if you want to solve any questions on this, you need to consider when n is greater than or equal to 2. And I told you what that thing implies from that lesson plan A rather. So I said that here in this case, we are going to be making use of, we manipulate by saying this n reduced by 2 of x, that's tan n minus 2 of x. Then to have the same thing for tan nx. So you need to multiply this by tan square of x, then dx. So that means in this case, we've not done anything wrong to the question. When you have tan n minus 2 of x, times this, that means you are actually trying to add up the powers. N minus 2 plus 2 of x dx. So this cancels this, you still have tan nx dx. So I've not done anything wrong with the question. So you see the same thing. These two still says the same thing. And then from here, in this case, we need to, because I'm actually saying tan square x directly. So that should remind me of trigonometric identity, which says that 1 plus tan square x equals what? Remember, that's x square x. So if I make tan square x the solid formula from here, I will end up having what? Sec square of x minus 1. So I'll try to substitute this back into the expression I have here. So in here is equals to integral of, this is where I actually stop. So I have tan of n minus 2 of x. Then I have tan square x. Tan square x is now sec square x minus 1, then dx. So if I open up this bracket, I will end up having integral of this multiply this. I have tan n minus 2 of x times sec square x, right? Then if this tan n minus 2 of x multiply minus 1, then I'll end up having minus tan of n minus 2, the same thing of x. Remember, all dx. So the next thing to do from here is that we have in to be equals to, so let me just try to split it up. Integral of this dx, then minus integral of this dx. So that's what I'm going to do now. So I'll be having integral of tan of n minus 2 of x sec square x dx minus integral of tan of n minus 2 of x dx. So looking at this, it is clearly seen that I can decide to use integration by part here. And here in this case, this is telling me, or this indicates that if I have in, I have tan nx of integral of tan nx dx. But now if I have n minus 2, this is just in minus 2. So I don't have any business with this. So this is what I need to simplify now. So in this case, I have to make use of integration by part, such that we let u to be equals to tan of n minus 2 of x, right? And we let dv represent the rest of the expression there, that's sec square x dx. Now if I need to find du simply implies differentiate this. That is, differentiate this expression means this comes down, you write n minus 2 first. Remember, this du dx, n minus 2 comes down, times differentiate tan x, that's sec square x, times repeat everything back, that's tan subtract 1, n minus 2 minus, I have minus 2 here, I have minus 2 in this case. So if I subtract 1, I'll be having minus 3, right? So that's x. So if I multiply both sides by dx, normally, by dx, I'll end up having du equals to n minus 2 sec square of x tan n minus 3 of x then dx. Now here in this case, I need to integrate both sides to generate my v, because I will need v in the formula. If you integrate sec square of x, this is a standard integral, that should be tan x. Yeah, that's antiderivative for sec square x. So next thing to do here is that we need to substitute. So that means I'll be having in equals integral, the whole of this integral simply implies integration by parts. That's uv minus integral of v du, right? Then minus, this has already become I of n minus 2. So I'll make it more simplified enough. So here in this case, the next thing is, what's my u? The u I have is what? From this case, u is tan of n minus 2 of x, right? That is u. Then what is v? V is tan x times tan x, right? Then minus integral of v is tan x, right? Times du is n minus 2, this du here, n minus 2 sec square x tan n minus 3 of x then dx. So this is actually equivalent to, when this multiply this, by the rule of indices, you have the same base but with different powers. That will be n minus 2. There's an invisible one here, minus 2 plus 1, that is minus 1. So I'll end up having tan is equals to, this is equals to tan, this gives us tan of n minus 1, right, of x, done. Next is minus, let's bring this constant outside, n minus 2. Please make sure you put inside the bracket, it's very important. So when this multiply this, I have 1 here, the minus 3. I'll end up having tan, that's minus 3 plus 1, that's n minus 2, that's minus 2. Then I have sec square x then dx. So whatever I need to do from here is to just remember that I've once said that sec square x is 1 plus tan square x. So just substitute, and then from there you will get your final answer. So next thing to do from here is that we have in equals, this is where I stop, tan of n minus 1 of x minus n minus 2 close bracket. Then we should have tan n minus 2, this, there's x here, sorry, x, then this x square x means I have 1 plus tan square x from trig identity, 1 plus tan square x then dx. So if I open up the bracket, in will be equals to tan of n minus 1 of x, so I'm trying to open it straight up once and for all, minus n minus 2 integral of this, the whole of this expression here is multiplying 1, so that will give us minus n minus 2 integral of this times 1 will still give us tan n minus 2 of x. Minus times plus is minus, so the whole of this expression, when it's multiplied this, n minus 2 is outside, integral is there, so tan n minus 2 of x times, sorry, there's still the x here, okay, tan n minus 2 of x times tan square x, that should be tan of minus 2 plus 2 cancelled, so I'll have n left, x then with the x. So this thing that I have here simply implies whatever I have left here implies I have in equals tan of n minus 1 of x minus n minus 2, right? This, trivially, I'm very sure you are familiar with this now. Tan n minus 2 of x dx, from the assumption right from the beginning here, that will be in minus 2, right? Then minus n minus 2, then this tan nx will be what? in. So then you know what to do from here. Collect like terms. In and this in, you collect it together. So then I'll be having in. When this comes like this, I have plus n minus 2 of in equals, then what else do I have? Okay, then I have tan of n minus 1 of x minus n minus 2 of in minus 2. So this is what I have. Yes, this is what I have. So the next thing we need to do from here now is that, so from here in is common. Cancel this, I have 1 plus n minus 2, right? Then here I have tan of n minus 1 of x minus n minus 2 of in minus 2. Now, remember, there's something missing. Whatever I've been doing this morning is actually for all this integration by parts, for what I have here. And that's what I've been trying to solve. Remember that I've not put this minus in minus 2. Remember, for this one, it is not there. Whatever I've been doing this morning is for uv minus integral of v. Uv minus integral of v du, right? Then that's where I actually stop. So I remember that we still have minus in minus 2. So here in this case, we still have minus I, this result I have here, remember, okay? So in minus 2. So here in this case, I'll be having in open bracket. When you add this up together, you have n minus 1. 1 minus 2 is minus 1. Here I have tan of n minus 1 of x minus minus. So you know what this implies? So I have minus what's actually common? In minus 2 is common, right? It's common. So whatever I have left should be n minus 2, right? If this cancel this, I have n minus 2. So for me to have a negative sign here, this n minus 2 is there. For me to have a negative sign here, that will be minus times plus. Because if I end up putting minus, that's minus times minus, we end up giving plus, and that's not what we are meant to have. So this here will be plus. Then if this cancel this, I have 1. So I hope you understand that logic. So here in this case, I have n minus 1 of in equals tan of n minus 1 of x minus in minus 2, right? So when you sum this up together, you have n minus 1. Yes. So divide through by, or multiply through by n minus 1. Let me just say divide through. So when you divide through by n minus 1 by n minus 1, this cancel this. So whatever I have left here now is in. Trivially, in is equals to whatever you have here. I can write this thing as 1 over n minus 1 tan of n minus 1 of x. So this cancel this, minus in minus 2. So this is the final answer for what we have been solving so far. So in conclusion, remember that this in is an assumption for tan of nx dx, right? Remember, and the final answer is what we have up there. Okay, this expression, and I think this is correct. Yeah, it's correct. So this gives the reduction formula for what? Tan nx dx. So guys, meet me in the next video for cot nx dx and sec nx dx. Thanks for watching. Please remember to subscribe. Thank you very much.